I just wanted to go over a few helpful hints before you take the AP exam on Tuesday. Ha ha! You guys are going to do great. So we're just going to quickly go through this cheat sheet, which I hope all of you already printed out. It's been on my website for a while. But before that, let's just go over a couple of things. If you have not done the exam demo on your phone or on the device that you're doing the AP Calc exam on, do that now and do it a couple of times. On exam day, turn off your notifications on your phone and tell your friends and family not to contact you on Tuesday from 1:30 to 3. Be sure you have your AP exam e-ticket. You should all have that by now. They were going to email that to you 2 days before your exam. If you didn't get the email, it will be in your College Board AP, My AP account. Make sure you have that today. Ahead of time, have at least 10 pieces of paper in 1/2 by 11, doesn't matter if it's lined or not lined, with your AP ID number written on the top and your initials on the top of each page. That's important. You don't want to be messing around with that during the test. And have that checklist filled out that they sent to you, either through email or it's again on your My AP. Print out your cheat sheet. Have any other notes that you want. Have your textbook if you want. Have any of the free responses there that you want. Have those available and organized so you don't waste time looking for stuff. Have your graphing calculator. Remember, nothing on the test is designed to require a graphing calculator, but you may use a graphing calculator. Remember that this exam, particularly this year, is loaded. It's not designed for you to finish it. So start by doing the parts you know how to do first. So if you look at part A and that looks good, do it. Part B, ooh, looks good, do it. Part C, ooh, looks bad, skip it. Do part D, looks good. Do part E, looks good. Part F, looks bad, skip it. Come back to part C, see if you can do something there, right? If you skipped a part, this is rare, but sometimes they say, use an answer from part B and part C. If they do that and you did not do part B, make up an answer, be obvious that you're doing that. Use that in part C and you can get full credit for part C. Stay confident. Typically, around a 50% is a 4. Around a 60 or 61% is a 5. Stay confident. You're not going to finish the exam, so just stay confident. Use correct and clear notation. Remember, we've talked about this. Don't say things like the slope or the function. Use labels like f of x, f prime of x, f double prime of x. Don't waste time simplifying. Even if it's like a Riemann sum, you do not need to simplify. Don't waste time simplifying. And this is essential. Stop with 5 minutes remaining. They're giving you 5 minutes to take all of your pictures and then to hit finally the submit button. Don't try to madly do more work. When that timer turns red and you have 5 minutes remaining, stop doing the math. Start taking a picture. You're going to take a picture of the whole page and then a picture of the next whole page and a picture of the whole next page and a picture of the whole next page. I think you can take pictures of up to 5 full pages. When you have all your pictures taken, then and only then do you hit submit. If you haven't already, print out this cheat sheet that's on my webpage. We're just going to go through it. Not everything, but we're going to go through some of the things that I just want to stress. I think everything on the first page people are comfortable with. Remember, if they ask you to show that a function is continuous at a point, you really have to use limits. The official definition of continuity is when the right-hand limit equals the left-hand limit, which also equals the y value. So for example, if I have a piecewise function, if I'm coming in from here and I'm coming in from here, the right-hand limit agrees with the left-hand limit, and there's also a filled-in hole there. In other words, the value is the same. That's the official definition of continuity. The intermediate value theorem, one of our existence theorems. If you have a y value here and a y value here and the function's continuous, then you have to have a y value in between. Whenever you are stating one of our existence theorems, the intermediate value theorem, the mean value theorem, the extreme value theorem, you have to state the precondition. For the intermediate value theorem, the precondition is that the function is continuous. Okay, I'm on the second page of the cheat sheet. Let's see, limit definition of the derivative, all of those rules, all those trig derivatives, they're all right there. Derivatives of exponentials, derivative of natural log. They put the derivative of log on here. That's not in the curriculum, but it doesn't matter. Next page, chain rule, obviously. Derivatives of inverse functions. We haven't done that for a while. If you recall, there is a cool formula for finding the derivative of an inverse. But I think the easiest way to find the derivative of an inverse is just to switch the x's and the y's. In other words, write the inverse, and then take the derivative of that using implicit differentiation, dy dx. So I'm on the next page now, the cheat sheet, L'Hopital's rule. Remember, you can use L'Hopital's rule to find the limit of a function if and only if that limit is 0 over 0 or infinity over infinity. Remember with L'Hopital, if this is the case, if you get a limit of 0 of 0 or infinity over infinity, then you can take the derivative of the top function, take the derivative of the bottom function, and find the limit that way. And you can use L'Hopital's rule multiple times. Next on the cheat sheet, position, velocity, acceleration, these particle things. This is important. This is a kind of a popular topic. X of t, if I'm calling that the position function, they can call it different things. Of course, the derivative of the position is the velocity. The second derivative of the position is the first derivative of velocity, which is acceleration. A particle speeds up when the velocity and the acceleration have the same sign. So if my velocity is positive, that means I'm moving to the right, and if my acceleration is also positive, I'm speeding up. If my velocity is negative, that means I'm moving to the left. If my acceleration is also negative, I'm speeding up. If velocity and acceleration have opposite signs, then they are working against each other and I'm slowing down. Okay? But every once in a while they're sneaky and they talk about when is the particle's velocity increasing. Remember, velocity is different than speed. Velocity increases only when the acceleration is positive. Okay. Also, occasionally they'll ask, is a particle moving towards or away from the origin? So if x of t is my position and v of t is the velocity, you just have to know where the particle is. If it's in positive land, that means I'm to the right of the origin. If it's negative, I'm to the left of the origin. If velocity is positive, I'm moving to the right. If velocity is negative, I'm moving to the left. So to know if your particle is moving towards or away from the origin, you have to know its position, know where it is, and the direction it's moving in. Now I keep saying moving right and moving left, of course, depending on the orientation. Velocity is positive, could be up. Velocity negative could also be down, depending on the story. Finding lines tangent to a curve, that's classic. We've practiced that a lot. Remember, if you have a function that's f of x, you find the slope just by finding the derivative at that point. And then you find a point. And the slope point point-slope form of the line is fine. Do not spend the time to find a y-intercept. That's a waste of time. Remember too, if you are using a tangent line to come up with an estimate for a function value, you have to look at the second derivative to see if that estimate is going to be an underestimate or an overestimate. If the second derivative is positive and the function is concave up at that point, any estimate on the tangent line will be an underestimate. If instead your function at that point of tangency is concave down, in other words, the second derivative is negative, then any estimate that you find using the tangent line will be an overestimate. Related rates on this cheat sheet, they have a few formulas that show up a lot. Remember, if you haven't done a related rates problem recently, do one, at least one. You can look at our website when we did the unit or do some of the free response questions. The height of a tree problem recently was a good related rates problem. Remember the whole thing about related rates, here's the area of a circle, is you're looking for a relationship between the rates at which the things change, the variables change. So you're always taking the derivative with respect to time. So the derivative of this would be 2 pi r, and then chain rule times dr dt. So do a related rates problem if you haven't done one recently. Okay, Extrema is a big one. Extrema is a big one. Minimums, maximums, absolute mins, absolute maxes. You know the drill. I'm not going to go over it here, but it's here on the cheat sheet. Remember, concavity has to do with the second derivative. Slope is the first derivative. You have a maximum on a function. When your derivative goes from positive to negative, you have a relative min on a function. When your derivative goes from negative to positive. So make sure you feel very good about all the extrema and look on your cheat sheet. Mean value theorem, remember, is where your average rate, and remember average rate is just slope. Change of y over the change of x. So your average rate, or your slope, must equal the derivative at least one point. Remember, for the mean value theorem, you have to state the precondition, which is the function must be differentiable. And if a function is differentiable, it's also continuous. Extreme value theorem is also on this cheat sheet. It just says if you have a continuous function on a closed interval, then there has to be an absolute max and there has to be an absolute min. The precondition for that is continuous on a closed interval. Okay, we're on the next page. Riemann sums, I think you're good with that. Midpoint, trapezoidal sums. If you haven't done any practice of these, there are quite a few of the free response questions had those. Practice those. Fundamental theorem of calculus. I think you are good with that. The one thing they don't have on this sheet is really a clear rewriting of the fundamental theorem of calculus. So the fundamental theorem of calculus rewritten is basically, if I want to find the value of a function at a point B, and I know the value of the function at point A, then I can start with the value of the function at point A and take the integral from A to B of the rate of that function. Okay? This is classic. So if you know the rate at which something is changing, this is the amount it's changed, and you add that to the starting position. So for example, if this is a particle, if I want to know where a particle is at time B, I know where it is at time A. This is the change or the displacement in the particle from A to B, and that's my rate. Classic. Fundamental theorem of calculus part 2. Remember, was taking the derivative of an integral. And you take the derivative of an integral. Let's say this is a constant. Let's say that is an expression in terms of x. The derivative undoes the integral, and that's just f of u times the chain rule, du, right? So for example, if I'm taking the derivative of an integral from -1 to 3x of, I don't know, the sine of x dx, then that would be sine of 3x times 3. Right? I should really have used a dummy variable. you usually have a dummy variable here instead of x. But that's the fundamental theorem of calculus part 2. More on the cheat sheet, indefinite integrals. Do not forget the plus c. U substitution, if you haven't done some U substitution practice, do that. Remember with integrals you can split them up. So if I have a to b of f of x plus g of x dx, that can be a b of f of x plus a to b of g of x. That's handy to remember that. If you have a to c of f of x and b is somewhere in between a and c, you can also split up your integral like this. Good to remember those properties. So go ahead and look at these properties here of the integrals. The last unit we learned differential equations. AP people love differential equations, so make sure you know this through and through. If they give you a differential equation and they ask you to solve, the only way we know how to solve is separation. These are always big point earners, so make sure you show each step. Separate the x's and the y's, or your two variables. This is the point. Some people just do the next step and they forget to put the integral. You will lose points. You have to use correct notation. You must put the integral. Here, if I have a y raised to the 1, that's the integral, the indefinite integral of that is the natural log of the absolute value of y. 1/3 x cubed plus c. Very important to put the plus c. And then you go from there. Don't forget to show each step and to not forget your integral. Very important. Other things about differential equations. A side note, let's say I had something like this instead of what I just had. That's not natural log, right? That's a very easy mistake to make. You would rewrite this as y to the negative 2, and the antiderivative of that would be that, right? Okay, that's a side note. This notation is used a lot in differential equations. Remember, it's just notation. That means second derivative. That's all it means. So let's say they asked to find the second derivative, and they gave us this differential equation. Well, the second derivative would be, well, let's first just rewrite this. That would be 1/3 y minus 2. So the derivative of 1/3 y is 1/3 times the derivative of y. Don't forget that part, the chain rule. That shows up a lot. And then we'd say, oh, well, dy dx is just this. So I'm going to replace dy dx with what dy dx is. And so my second derivative would be something like this. This shows up a lot in differential equations. Also with differential equations, if they're giving you a specific value, don't forget to plug in your x and your y and find c. And last but not least, look at the beautiful gift I gave you. The unit circle, your old friend. You can use it this year. Very nice. So have that out in front of you. There are also trig identities, which I doubt will show up, but might as well have them there in case they do. You are all so well prepared for this exam. I know it's been a difficult way to end the year, but you've all hung in there and you're all here. So I'm so proud of all of you. So be confident, get a good night's sleep, sleep like a greyhound. Have a good breakfast. Log on at 1:30 on your phone or wherever else you're going to take this exam, and know that you are well prepared for this. You're all smart whippersnappers. I'm so proud of you. I miss you all. But I hope you can have some fun on this exam, and let me know how it goes. All right, be well, good luck.